Hey, hi guys, Madhav this side. So this is continuous series from the JUnit. From this video, I am planning to execute programs based on these annotations. So let's start one by one. So before start the execution, I just want to tell you some setup related to this JUnit. So this is just a Maven project, and there is no any business logic in it. Just a standalone way of doing some JUnit testing. And if you see the pom.xml, there we need to provide one dependency. This dependency will provide you all junit5 supported libraries. No need to provide any extra library. This is all about the setup part, and let's see the execution. So this is very basic example. This will describe how do you start the basic JUnit test in standalone manner. So here I just written one test method. There is no any logic in it, just a soap message, and there I written one asset equals a standalone way of testing. I already declared here too, and I'm just comparing here. If I let's give an handover to this junit5 platform, and what happened we'll see. I'm just right clicking, and there is one option called junit test. So this actually hand over to the junit platform. It will start execution about this particular chain. So there this this spring STS is beautifully displaying here. If you see the result, it's got success. So here my intention is there is one annotation here test. This is referred from the Jupyter API. In JUnit 5, if you want to start any JUnit test case, so this is how we need to define a method and annotate the test. So then the JUnit 5 will consider execution about these statements. There is no any business logic, just giving an idea how generally you can define a JUnit test method. Hope this gives some basic idea. And let's move on the next one. This is the second example. Here I will show you how we need to define the dynamic JUnit test cases. So if you want to write dynamic JUnit test cases, there is one annotation from the Jupyter test method test factory. If you say here, test factory is from the Jupyter. So this will help you to write dynamic JUnit test cases. And also, if you want to provide the dynamic JUnit test case, there is some like a method signature need to be followed like this. Method name can be anything, and the return type should be the iteratable of dynamic test. And correspondingly, we need to prepare the return type like this. So there is dynamic test. It's also given by the Jupyter, and it contains one of the method called dynamic test. And there you can define two arguments. The first argument called method name, and the second argument called definition about that particular test case. And with comma, and it considered this is one element in the list, and the second element we need to follow the same, like dynamic test is the class, and there is one a static method, and we can provide a method name like this in the first argument, and the second argument should be the definition like this. So based on array size, dynamically the test factory will get create multiple test cases once you run this program in a JUnit platform. So let me show you that execution part. Right click on this program and just give an handover to this JUnit platform. Let's see what happens. Now if you see the execution part here, so add test is 1 and multiply test is 1. So while running the program, based on the array size, it considered there are two elements in it, and two test cases got formed and it got executed. So here I just written one statement here for better understandable purpose. There we can write multiple statements also based on your requirement. So hopefully you get some idea how we need to write a dynamic test by using test factory. And I don't say there is a major advantage in the real world application when you go with the test factory annotation. Maybe in future we can see, but I at this stage I don't see a major advantage when you go with dynamic test cases. Now third one, nested or test classes. So before nested test class, there is no like major advantage here. So it's just for manageable purpose. Like similarly, if you see the nested Java classes, the purpose of defining the nested Java class is if a class logic is depend like tightly depend to a particular class and that is not used in any other area, generally people will declare the inner class. So their nested classes or inner classes will generally call it. So that is just for manageable purpose. So here also will be the similar manner. So you can write multiple nested JUnit test classes like this by annotating nested. Here I just written one method in this class and here also I written one more. If I run this, run in the sense we are giving handover to this JUnit platform. As I mentioned, JUnit platform has powerful user interface. Like any Eclipse or STS or any build tools can easily connect with it. So this is how I'm connecting with. Now if you see, there one JUnit test and there is one more JUnit test. Both names are same. This is how generally we can define nesting JUnit classes. And the fourth one, parameterized test. This is very useful in the real world application. So I will tell you what is the use of this parameterized test. So this will help you to define some parameter inside the method. If you see there is a line number 14, I declared one method and there is one, I declared one parameter here. So like a, and also we can provide the source of this parameter. There is one more annotation value source and I just declared strings and there I provided one name here. So what happened when I given this handover to the JUnit platform, based on this parameterized test, it understood that it needs to be passed some arguments while running this method. So the source of this argument will be the value source like here. So there, based on this array size, it will platform will call multiple times this method and it will display the result. So in this case, there is only one element, only one time this method will get called, and this logic will get executed and it will show the result. So here I just written one line of code in. So you can write multiple lines as well. And if you take one more example, so this is the method and there I declared some parameters. So here first argument will be the string and the second argument will be the integer and there I written some logic. And because of this parameterized test, I need to provide the value source as well. So there is a CSV syntax value or like a, what we called a name comma value kind of pair we can give. So apple is one and banana two, something like this. So what happened if I given this to the JUnit platform? So because of this parameterized test, it will try to pass these values while calling this method, and it will consider this is the source. And based on the size of this array, it will call multiple times, and all the time the result will get executed. Let's see. Right click on this and give an handover to the JUnit platform. Oh wait, it's not, wrong option we chosen. Let's correct it. Okay, now it got executed. If you see this, it's called it, this method get called how many times? 4 times, based on the size, and all the time it get displayed and all the asset statement got executed. And here we have only one element in here, and it get executed only one time. So this option is very useful if you have data in your handy and if you want to test a particular logic. Okay, so the last one, tag. So this tag usage will be like this. You can annotate a tag, and there's some meaningful name to this particular tag. And so if you see this class having multiple tags are used, this method is comes under tag called interest, and this is comes under taxes likewise. And when you come to execution part, if you see here, I written one suit, and in the line number 11 I included tag called taxes. So what happened, if I run this example, it will pick only that tax related test case, not the other one. So this I already discussed in the previous video. Like a tag is used to filter the test cases. This is how we need to filter and execute. So that's all guys, thank you. We'll continue the next.